In this video, we will go over an exercise on the returns to scale. Remember, the returns to scale is a long-term feature of the production technology, and we have three different notions. One, constant returns to scale. Second, increasing returns to scale. And third, decreasing returns to scale. So we will give an example of production function for each one of these three features. So let's start with the production function Q given as 2K plus 3L. We want to claim that this production technology displays constant returns to scale. And so for that, we remember the definition. If I increase the input, each one of the input, by a fixed proportion, then the output increases by the same proportion. So let's take K to be 1, L to be 1. We can find out my output is 2 times 1 plus 3 times 1 turns out to be 2 plus 3 equal to 5. To verify that it displays constant returns to scale, I could change the capital and labor exactly by same proportion, so I will double it. You can change it by any proportion, output will display the same feature. So I have K equal to 2, L equal to 2, Q is 2 times K, so 2 times 2, 3 times L, 3 times 2, so I have 4 plus 6 turns out to be 10, which is exactly 2 times the output when K was 1, L was 1. So that's the proof that this production technology displays constant returns to scale. Incidentally, Q equal to 2K plus 3L is a perfect substitute production technology. Perfect substitute production technology. Now I will go to the example 2, which is increasing returns to scale. So now let's take Q to be K times L. So this is a Cobb-Douglas production technology. With coefficient K to the power 1, L to the power 1. And let's start with the same capital labor combination. K and L equal to 1 gives me Q equal to 1 times 1 turns out to be 1. Okay, to verify that it displays increasing returns to scale, I will double each one of the inputs. So I will take K to be 2, L to be 2, and now we can find out Q is K times L, 2 times 2, which is 4, which we can see is 4 times the output when K and L were 1 each. So this is 4 times Q when K was 1, L was 1. So increasing returns to scale. The third one is the decreasing returns to scale. So for this, I will come up with a production function where Q is equal to K to the power 1/4, L to the power 1/4. Remember, this is also a Cobb-Douglas production technology with the index, the power of K to be 1/4, L also is 1/4. And I start with K equal to 1, L equal to 1, which means Q is 1 to the power 1/4, 1 to the power 1/4, I get 1. Now let's double both the inputs. So I will take K to be 2, L to be 2, and see what is the output. So if K and L are both 2, then Q is 2 to the power 1/4, 2 to the power 1/4, and we know when we multiply the powers will add, so this is 2 to the power 1/2. Quarter and quarter add up to 1/2, which is square root 2, or if you use calculator you will find something like 1.414, going on and on, which means when I doubled all the inputs, output increased, but by less proportion, in a smaller proportion compared to the increase in input. So 100% increase in input led to only 41.4% increase in output. So that's the decreasing returns to scale. And this is a good point to stop.